Good afternoon. Welcome to the session on virtual private data center architectures. My name is Ken Owens. I work for Savvis Communications. I'm the Vice President of Security and Virtualization Technologies. I have with me a case study also from the Commonwealth Bank of Australia. So I have Nick Holdsworth with me, who come up about halfway through and kind of give, from a financial services industry viewpoint of a private cloud architecture. And the two kind of stories mesh together pretty well, but mine's more from a technical side and Nick's is more from a business side. So I think it should be pretty enjoyable. So before I dive right into kind of the technical architecture side of things, I want to just kind of start with what's the problem we're trying to solve. Right, so what's the problem statement for why clouds? Why are you guys here and interested in clouds, right? Or why is the industry telling you that clouds are kind of the next evolution? And what it kind of comes down to is what we like to call the enterprise IT challenge, which is how do you balance your workloads across different infrastructures in a most efficient way that gives your business the value that they're looking for, and at the same time some of the agility and some of the quick deployment needs that they're looking for. And so if you look at the infrastructure domain, you see a lot of different components, right? So there's networking, there's a data center environment with technicians and cages. You have your storage components, your compute components, kind of all these discrete kind of technology components. And then above that, you have this application portfolio that is what the business is really interested in, right? Here's what they want to deploy into this cloud environment. And there are different types of deployment models that you can deploy into this. There's infrastructure as a service is one type of a deployment model. There's platform as a service, which is the next level up, and then you have software as a service. And the infrastructure as a service domain is pretty much just in that lower part of the picture here, the infrastructure domain. And the infrastructure as a service is really looking at how do you take compute and storage and put them together, and how do you take servers and connect them to a network, and how do you take your SAN and connect it to that same network. Kind of looking at consolidation of your hardware environment, if you will. The platform as a service then can kind of take that a little bit further and say, you have a development framework or development platform that you're using. How do I integrate that fabric or that platform that I'm developing on into my infrastructure and layer on value-added development services to my infrastructure? And then the software piece is where I think cloud really shows some of the advantages of where we're trying to get to in the future with cloud is, how do I bundle my applications in a way that make them agile, make them rapidly deployed into this environment, and allow them to be elastic in nature. So when you look at that, some of the interesting research that we did, kind of brought us back to a taxonomy of cloud services. And so, there is no way to kind of take all your hardware and consolidate it and say that's a cloud. You have to really look at it more from what types of things do you want to do with a cloud. And so the first thing we looked at was, with an infrastructure as a service play, you have different technologies like Xen and VMware and KVM type of services you could deploy on. You have the vCloud based services, and the vCloud Director, kind of the new product that VMware announced this week. There are things like disaster recovery and virtual desktop services you can build. You can build lab services if you're just interested in kind of doing a lab play. At the next level up, when you get to the platform as a service layer, that's where you have things like your Java environment. That's where you have Python or Ruby, .NET type of environments. But that's also where you have some interesting things like queuing services. So you could offer kind of a queuing service on top of your infrastructure and allow different workloads to request services from the queuing service, request to be queued into a certain workload. When you look at the software as a service layer, that's where the applications need to then know how to take advantage of the underlying platform and infrastructure components to a certain extent, but they also want to be elastic in nature and have a lot of flexibility in the way they get deployed. So you look at the taxonomy, and you kind of think about what's the problem you're trying to solve, and what are the different components for that problem. The first thing that we wanted to do is kind of develop this reference model for the architecture. And so the first piece of the reference architecture is I mean, for the reference model for the architecture is your access. How do you get into this environment? Is it you need private connectivity? Can you use internet access? What is your access method, right? The next piece then is how do you secure that perimeter into your environment? And this secure component could be, maybe it's VPN with IPsec, maybe it's certificate-based. It could be just a perimeter firewall. Identity management type of services, usually you want to sit that out of that location so that you know who the user that's accessing your environment is authorized to get into your environment. The next piece then is, kind of how do you determine which location you want to service these applications at, and how do you pick which location is the most available and the most, has the most resources available to process those. So then, what we looked at was, a typical three-tier architecture of web, app, and database. And so if you look at, a typical three-tier deployment model, you'd have, security boundaries between your tiers. You'd have elasticity within your tiers and across tiers. You'd have the ability of your security policies to protect you at your different physical boundaries, right? And then you would have a physical SAN kind of component. Could be NAS attached. It could be, straight fiber channel attached type of SAN. But you have a high-speed, low-latency type of a SAN environment. The next piece then is, so once you have kind of your N-tier architecture as a reference model, what type of availability requirements do you have? Is this a highly available, you need to be always up? Do you need an active-active type of deployment for this? If this site goes down, what's your failover for this? Does this application deployment need to have a failover type of location? And then the next piece is the performance side of it. How do you understand the actual performance of your application? So there's lots of good tools and ways to measure the infrastructure, and if the infrastructure is up or down or how many CPUs you're using. But what most businesses want to know is, what's my application performance? What does my end user experience when they're going into this environment? Are they able to get the response time they're looking for? And so we wanted to kind of provide that level of visibility back out to your end users so that the enterprise users can see, the business users can see what they're actually getting out of this service. And so with kind of those two things as the baseline, right? Understanding kind of the taxonomy of the different types of services you can deploy, and then understanding kind of having a reference model in mind. The next thing I wanted to kind of talk through was, for an architecture, how do you look at what a cloud is, right? So a cloud isn't all of those things. Right? A cloud isn't just a bunch of hardware and software, and it's not just making a nice, pretty picture that shows three tiers of an architecture, right? It involves a lot more than just consolidating hardware and software. And so what does the industry say a cloud is? So when we researched the industry said that a cloud has to be lightweight, which makes sense. You want a simple interface that's easy to get up and running on. There have to be no commitments, right? To be a cloud, you can't require a 3-year term, right? So it has to be no commitments, and it has to be very agile, quick in and out, short-term usage patterns, but also support long-term patterns. So in other words, there's no need to force something out of the environment. There's no reason to force you to stay in it for longer than you need to either. Instant delivery. So, a lot of you guys are probably familiar with the way traditional IT is, 45 to 90 days to deploy servers, right? And so a lot of people look at cloud and say that's the only reason for cloud is that you're trying to consolidate how long it takes to get those servers deployed. And that's not really the case for cloud, but there's definitely an attribute of cloud that, you want to get these services, the business wants services available to them almost immediately, right? Not push of a button immediately, but not weeks or months to get them up and running either. And so there's kind of a fine line between immediate delivery and, a few hours. But within some short period of time, you're looking to get these services available to you. The next attribute is usage billing. And this kind of goes back to the, thinking about, cell phones, the way the whole industry has evolved in other environments, right, with, cable and with power. Customers only want to pay what they use. They don't want to pay for all this infrastructure that you've deployed within your cloud, right? They want to only pay for what they've used when they use it, and for only the amount of time that they use it for. And then the last thing is when you're looking at an architecture, you don't want to build something that fits your current demand or what you think your current demand is, but has no future scale capability. And so with the architecture, to meet some of the requirements for being highly scalable, which is what a cloud is looking for, you have to kind of take that back into your infrastructure design and say, well, how do I make something that's highly scalable, that can be added? I can't start off with a huge amount of capital, but how do I add to this incrementally as the demand requires me to? So, you look at all those market attributes of what make a cloud, but is that really all? And I don't think that's all you really need for a cloud. So I think, security is a good question. Are there security concerns that you have with the cloud? How about application development architectures? Do they have any kind of dependencies between them? Do databases and application servers have any sort of, reliability and availability and latency type of controls or requirements that they need to be met, right? How about disaster recovery? Is that important to the architecture? What about your end users and their application experience? Like we built, we talked about in the reference model. Most, users want to see a dashboard of what type of performance they're getting with their application. So if you take those additional, those initial market attributes that we went through, and you add enterprise security controls, most, cloud architectures need to support some type of a compliance, right? Whether it's PCI compliance or FISMA, depending on which, industry, you're building a cloud in or looking to buy a cloud from. You want to know if it supports compliance. Do they have true firewalls, right? And by enterprise-grade firewalls, that usually means they're stateful. They have logging capability. You have the ability as a consumer to provision the firewall rules and define the firewall policies, your security policies at your boundaries, right? And so, there are other firewalls within the architecture. And the next thing is, is security just an add-on component that you plug into the side of your cloud, or do you want, security to be integrated at the virtual layer? Do you want your virtualization environment to have built-in security controls and security boundaries in a similar manner to what you have in the physical environment, but not physical, virtualized, right? From a solution QoS standpoint, you want to be able to guarantee performance, right? I think that's today cloud is kind of a best effort solution, but I believe what enterprises want from a cloud is guarantees. They want some performance requirements met. They want SLAs around their performance for their application. And so one thing that I think, is important with the cloud is that it supports different types of quality of service, and you have variable options. Not all applications need to be built on a cloud that is, 5 nines available, right? But not all applications can work on a cloud that is 2 nines available either, right? So you kind of need a solution that gives you a nice choice of options between different types of availability. From your data access and protection model, things like being able to do, this kind of goes back to the disaster recovery type of comment, being able to provide, lifecycle management of data and classification of your data, being able to replicate data from one location to another are all key components of a virtual private data center. And then the last piece is, kind of going to that highly availability and scalable type of discussion. And this is where you don't want to be locked into, certain types of VM profiles. You want to be able to have the ability of providing small images or large images, right? You don't want to be constrained by what a architecture says you need to have, like one size fits all or just a few small combinations of sizes. Dynamic resource utilization is a key component for flexibility and agility, because you want to make sure that as your environment grows, that your instances can grow with your environment, or can elastically grow your environment as they grow. Load balancing and being able to kind of do site selection and local availability capabilities are both important aspects of being a highly available solution. And then the orchestration of all of this is also another component that's important to think about, because deploying into a cloud solution is more than just taking a configuration parameter and just dropping it on a bunch of endpoints. There's how do you kind of execute your transactions from an application standpoint, and how do you allow that to scale as your application architecture scales? So when you take kind of all of those different components you kind of come to a nice reference design for what the architecture looks like, right? And it consists of, primarily three main components: your cloud OS type of layer, the layer that kind of drives the configuration of your environment. You have an infrastructure component, which is where the hardware and software of your environment resides. And you have a management component that helps you, basically manage the environment and support the environment when things go wrong. And so from the cloud OS standpoint, that's kind of where you have your business orchestration layer. That's where your database and all your configuration management type of components reside. And that's where kind of some of the intelligence that we'll talk about in a few minutes resides within your infrastructure. It talks to an orchestration layer that then kind of abstracts away what your OS provides from what your infrastructure is looking for. And so there's kind of a whole web services type of SOA reference architecture here, so that these interfaces are all web service interfaces that can be plug and played with different components over time. So you're not locked into one specific vendor or one specific solution. So there's no vendor names up here for that reason. The orchestration piece that talks to the infrastructure is important because there are certain dependencies on how you deploy your application into an environment. It's hard to deploy an application onto a VM that doesn't have an OS on it, right? And so it's hard to have a security policy in place if you haven't provisioned firewall rules before you let your VM spin up. And so there are certain dependencies that need to be worked out. But once you kind of have a rough idea of how you would manage this architecture, from your provisioning standpoint and what you'd provision when, you can kind of build that into a set of rules that say, when you provision the system, go do this step one and this is step two. So it's not a complicated orchestration. It's just thinking through how you need to do the orchestration is important. Some of that depends on this infrastructure box, which, for most clouds, this is pretty much the same. You have your network components and your storage and your compute and your security components. What's kind of different about this reference architecture is the need of a kind of a fabric that ties all of these together that I like to call the data center fabric. In my mind, this needs to be like a very high speed 10 gigabit backplane, maybe a 40 gig backplane. So a very high speed interconnect between all the different components within your infrastructure to enable really low latency and high speed switching. The piece to the left of that is probably of the pictures on this box up on the screen is probably the most important and the most critical to an organization. And it's the one that is not really thought about a whole lot, right? And so when you're thinking about an architecture, you want to understand, how do I manage this? How do I troubleshoot this? When my end user calls into the desk and says, hey, my VM just went down, how's the person on your desk going to understand what that means, right? What is a VM? Where's this VM at? What do you mean it just went down, right? How do I find this information about this? And so being able to do event management, SLA management, doing incident management as things, as events happen and as incidences need to be investigated, have the ability of kind of drilling into that incident to find out what's the root cause, right? And then, from the event management, having a feedback to your orchestration, your business orchestration layer that says, if you see this VM or this set of VMs, this VApp, spin up to a resource utilization of 40% or 50%, I want you to spin up 10 more VMs, right? Give me give me a copy of this VApp to help me balance that load a little bit better, and have that that intelligence built in between the support systems and the business orchestration environment. So I kind of went through these, so I won't spend a whole lot of time here, but from a cloud OS standpoint, a lot of the capacity, there's a lot of capacity management and a capacity understanding of this environment, from the compute, the network, the storage, a lot of different parts of the infrastructure. So kind of understanding your capacity and developing some algorithms around how you manage your capacity are kind of part of that cloud OS layer, along with the service catalog, service design, the provisioning manifest that needs to be created to help provision the infrastructure. The cloud orchestration piece, if done the way the architecture recommends doing it, is a very dumb layer of software that just takes your input from the business orchestration layer and just sends provisioning commands into your infrastructure. So it doesn't have much intelligence at all. It's really just meant to be an abstraction layer from your business orchestration to your your infrastructure. And all it is doing is executing the commands that you've asked it to execute. From the cloud infrastructure, the different components that are important here have to do with different kinds of network services and different storage services, and how you partition your storage, how you carve up different resources from the network, and how you put different QoS into your network interfaces. And being able to tie all of that together from the virtual network interface on the VM all the way out to the internet connection that you have connected to. Or if you're doing like a private MPLS type of network, you'd have QoS all the way through your MPLS network. From a systems management standpoint, being able to look at your events in real time, to be able to automate different response to events happening in your environment, and doing 24/7 security event and incident management is something that I think is part of this architecture by default, because this environment as a cloud environment is very elastic, and you want to understand what are the impacts and implications of events as they happen. So with that, I wanted to kind of show a real quick picture of what kind of a reference design might look like. And so within a reference design, I created something called a cloud site. And so I kind of wanted to go away from physical limitations. And so by saying a cloud site, I'm not tied to a physical data center, right? You could, in one of your data centers, you may have hundreds of cloud sites, right? So it's more of a logical construct of what you have your cloud services running in. And within that cloud site, I created a foundation pod. That foundation pod has all my management services, all the network services for the rest of the cloud site, and all the virtual services like firewalls and load balancing that are needed within the site and across sites. And then I create, what I call virtual data centers for the private virtual data center component of this that has the compute and the storage needed for that compute. And so the nice thing here is I've kind of showed at the top one constraint, and this isn't the only constraint, but one constraint to consider in your architecture are how many virtual servers, for instance, can you deploy. And so in Virtual Center 4.0, the limitation was 2,000 VMs or 200 hosts. And so this design kind of shows building for a constraint of 200 hosts or 2,000 VMs. But there's no reason why you can't add additional compute pods. So that's kind of the scalability thing, right? I can, as 4.1 went to 3,000, you can now add 3,000 to this if you go support 4.1, right? And 5.0 maybe is 10,000 VMs, right? And so if you understand what your compute and storage pods can support, you can start rolling out additional compute and storage pods within a virtual data center. So you're not really limited by what the design is showing you. You're just limited by what your infrastructure can support. And if you plug in a different virtual, different hypervisor environment, you just have to understand how that impacts your storage and your compute design to support that. It doesn't make you redesign your entire architecture. And then so the idea of a virtual private data center is to take, to kind of overlay across this infrastructure all of your LDAP type of requirements, all the URLs that have been provisioned, building, kind of a vApp container of all of your VMs, all of the storage that supports those VMs, all of your application configuration, so all of the components that have been laid on top of those OSs, all your application data, the dependencies those applications have on the components in a different part of the architecture, so like maybe the app and database dependencies you have, any kind of disk retention and management requirements you have. You kind of take all of these components, all your firewall rules, all your security policies, you put all of that into a container that I call the virtual private data center, and now that virtual private data center can be moved around within this cloud site or across cloud sites. And so you kind of free yourself from the physical hardware and the logical software boundaries that have been defined by layering another layer of abstraction across the virtual data center. So the next thing that I want to kind of go through was, I talked earlier about having different service profiles. And so at a high level, a virtual private data center should have multiple classes of service, not just one size fits all. And so if you think about maybe having a test and dev environment, you might want to have something like an essential profile that is, a little bit limited in its networking capabilities, kind of using the lowest end of storage possibly, not doing backups but just once a day, so kind of lower end quality, best effort type of service. Security being mostly just around ACLs or deploying like host-based firewalls. The next level up then maybe is for your non-mission critical type of data, and that's where you get more of a more around the security model and around additional networking capabilities. And so now you have more flexibility around what you can deploy from a resource requirements. You have less oversubscription in this model possibly. You have the ability of doing local failover with some redundant DR type of backup things. You have multiple tiers of service. Your backups are happening every 8 hours instead of once a day. And this is the level that in the architecture you kind of put in that virtual firewall component, right? Whether it's a vShield app firewall or it's a different VM safe compatible firewall from other vendors. That's the kind of layer you put in that virtual security component. And the key here is that Balance is trying to create that logical 3-tier architecture that you're probably used to in your enterprise data center, where you have your multiple tiers of applications talking back to a switch that has a firewall in it, and then coming back into the environment. And one of the keys with this solution is this architecture is to try to build a solution that gives you that same 3 tiers, but in a logical sense, with firewalls between each tier, but not having to leave the virtual infrastructure and go back out to a physical firewall to do that. And then the last tier is like an enterprise-grade type of service for more mission-critical applications. And the key here is to be more physical separation instead of logical separation. And so this is where you get you add on things like web application firewalls and IPS for security. You add the highest quality of service across the entire environment, both from a storage standpoint and a network QoS setting standpoint. And this is where you get into not only local high availability, but across site high availability. Just kind of shows the three different service tiers for the architecture and kind of the life cycle, kind of trying to support a application life cycle where you go through test dev to non-mission critical deployment, or test dev to mission critical deployment. And then the 3 use cases I want to kind of talk through that I think are a little bit interesting. The first use case is kind of what you're hearing a lot about at VMware this week, which is the hybrid cloud, right? And there's 3 ways to kind of look at a hybrid cloud. The current definition of hybrid cloud is a little bit restrictive, I think, in that you kind of move. Hybrid cloud means it's running either in your data center or in another data center, right? And you kind of have a way to move those workloads from one data center to the other. And that's kind of where most clouds are today. They have the ability of taking a workload in and running that workload and providing information back to the enterprise about that workload. The second use case is a little bit more interesting because now you can kind of wrap around that some of the OVF framework and be a little bit more portable between clouds. And a lot of cloud providers are here today also, where you can take your OVF images and you can move them around to different environments. But I think the use case 3 is the one that is the most interesting to a lot of providers, and I know Nick is going to talk a little bit about this from a use case that enterprises are thinking about a lot. Is how do I have workloads that are agile enough to move around between different clouds, and have some components that still reside in maybe my internal, like maybe my database sits within my 4 walls, but I want to put my application and web servers in whichever cloud can give me the lowest cost per hour at this given point in time, right? So kind of having more of a hybrid. What hybrid actually means, you're in 2 different locations or 3 different locations running at the same time. So I think I'm going to skip the demo because it's a little bit boring now that I'm thinking about it. So I'm going to skip over and let Nick Holsworth come up. And Nick is the Executive General Manager of CBA. And I'd like to thank him for coming again.
Great. Thanks, Ken. Afternoon, everyone. Look, what I want to go through, what all that actually means is that I'm responsible for design, build and operate for IT infrastructure and operations. And so one of the challenges that we've been looking at over the last year or 2 is how do we actually get to cloud And one of the things I think we've heard a lot about at this conference is that in some ways it's kind of consumer technology starting to drive enterprises, and it's not quite as simple as kind of zipping your credit card and jumping onto Amazon for a corporation, and especially for a bank. There's a lot of other things we need to think about, and I just want to take you through a couple of I've got about 5 slides here, and maybe just to get a bit of a conversation started around the types of things that we've worked through or thought about over the last year and a bit. So just to give you a quick view on who the Commonwealth Bank of Australia is, because some of you may not know, we're actually about the 15th largest bank in the world by market cap, and we can thank the global financial crisis for that. Most of the other banks went backwards, and we stayed where we were, so we went from about 50-something to about 15th. We make about $6 billion a year in cash, so we have a really good return on equity. And we're a full-service bank, so we do everything from running a high street branch, all the way through to insurance and trading, portals and insurance and investment and broking services. And in most of the markets that we're in Australia, we're number one or thereabouts in most of those businesses. So we're in a good place at the moment. So I think the first thing I wanted to talk about really briefly, and it's some of the things I think I'll state in here are somewhat obvious, but I think we have to keep reminding ourselves of them, because otherwise it's really easy to kind of get embroiled in the technology and forget about what we're actually trying to achieve at the end of the day here, because the business actually don't give much of a toss about technology, and they actually just want some outcomes. And some of the outcomes that we're looking at, I've put on the slide. So when we talk about cloud, and some people have tried to ban that word from their organisation altogether, but what we've tried to do is just define that, and what we've tried to define it as is really a business model. So rather than thinking about it as technology, we've tried to think about it as a couple of different things, and we try to think about that as technology. So how do you deploy some of the latest technology that's becoming available? How do you actually buy that out of the market? So some of the commercial models in the market are really just developing. And how do you kind of help those along and figure out how you buy this stuff, because we don't really want to build it. And also, what does that mean in terms of the operating model that you need to set up inside your organisation? So what role do you want to play in brokering those services into the organisation? And, at the end of the day, the business just wants some of the things I'll put on the top of that slide. So, life doesn't change for them in that respect. They just want, it's always, too slow, too expensive, and we can't get it fast enough. And they just want all of those things improved. And I think one of the things we've seen is that some of the things that are starting to happen in the industry, both in a technology and a market sense, we think will actually provide a step change in terms of how we can service the business, and that's why we're so interested in chasing after this. So one of the things I mentioned before was operating model. And what I mean by that is Ken kind of mentioned this as well, and he talked about that kind of service management layer. And if I take that up a couple of levels from a business perspective, then what this really means is that what are you going to do to abstract the technology services from the business? So all the things like how does someone find the service on a catalogue? How do they order it? How does it get billed back to the end user? How do they figure out whether that service is performing or not? If something's wrong, how do they call a service desk? How do we keep track of configuration items? How do we know where different workloads are running? How do we provision them? There's a whole myriad of things that we need to actually be able to do as a business. And the model that we've come up with from a CBA perspective is we've said, we want to be the broker of those things. So, my IT shop's moving more away from actually running IT services as such, or running boxes and applications. And we're starting to really develop that service management layer. And that's all about really tooling and about enabling the business to reach through that layer to actually grab services that we buy from the market, and then make sure that we know exactly what they're buying, and that they're putting their workloads on the right types of platforms, and that we know where the data is, and that we know that we can bill them and all those types of things, and we can manage incidents and problems and all that type of activity. So one of the things we actually did a couple of years ago, which was more by good luck than good foresight, was we actually started abstracting those services from the business. So we actually created a product management organisation within the operations team, and we actually said, we're not going to sell you things that look like technology anymore. We're going to try and get a little more customer focused about that, and we came up with about 400 products, and we priced all of those, and we figured out how we could actually understand the volumes of the business and allow us to catalogue those and actually sell them to the business in a way that we could show year-on-year unit price was going down, and we could continue to drive life cycle improvements in those products and services. And what we're really trying to do now, when I talk about, but now we need real agility, we kind of abstracted all that mess of technology from the business, and we tried to fiddle with all those bits in the background to make it look like we were providing things more as a service. But now we really want to push that back a layer more, and we don't just want to push it back to someone else who's going to do our mess for less. We ultimately want to push it back to someone who can provide us with that, real agility. So, the on-demand and pay-as-you-go and contestability. Just pushing that back to another party or an outsourcer, in traditional terms, actually doesn't provide any value. In fact, our costs would probably go up, and in our experience, our agility probably goes down. There's a bunch of kind of technical and commercial legwork to do, and once again, some of these will be things that some of you folks have worked through over the last years. So, in my experience, it's absolutely true. The more you can kind of virtualize in the short term, the easier it is to kind of start jumping a lot of those applications into the cloud. And clearly, a lot of what cloud's about is adding a lot of automation on top of that from a technology perspective. It's really about understanding workloads, and I'll talk a bit more about that in a minute. And one of the learnings we've really had is that it actually becomes really critical to understand what the workloads are you're running and what the attributes are of those workloads, because it's actually all about right placing those workloads, based on those attributes. And attributes could, be things like, security and latency and availability and those types of things. I think the business model is important. So, once again, how are you going to price this to your customer, or how are you going to bill it to the customer? So, if we actually get to a place in the future where, as an organisation, I can actually buy, workloads from a number of different organisations, be they, infrastructure, platform, or software as a service, and I'm assembling those and I'm making sure I can bill them and I've got workloads running in the right place, then how do I actually price those to a customer? So I've got to add some cost to manage, the governance layer that I've got, and I need some investment money, and clearly, more and more the consumers in the business can actually go straight to the market to buy those services. So how do I actually, compete with the market and make sure that, I can actually justify the prices that I'm charging my customers for those services? And once again, I think one of the things that the cloud model actually does enable potentially, if we can get to buying services and with shorter time constructs, then let's not try and get this thing perfect on day one. The way we're trying to go after this is let's just deploy, and then as long as you're not tied into long-term contracts and you do have some agility, then how do you actually just iterate really quickly? Because there's a lot of learning to do. And, I think as most of us would have seen over the last couple of years, this whole game is really accelerating fast. The technology is taking off and accelerating. We're now seeing people in the market who actually will offer, services on a 30-day basis or, whatever the case may be, they're enterprise grade. And, we need to keep up with the pace of that change. And so we really want to, just my view would be just get stuff out there, get it running, and then actually iterate and learn as you go. And as long as that's creating value in the short term, either financially or in terms of, what you can offer to the business, then that's got to be good. One of the things that we have going on, which is kind of interesting, is that we have quite a few services that are outsourced as well. So in about 2 years, all of our contracts expire. And we've got about $700 million worth of services that we need to figure out how we're going to buy. And, so we're trying to think about that in a couple of ways. One is that, we're putting about a 2 to 3 year time horizon on transformation. And we're saying, there's some things that we're just not going to be able to transform in that period of time. We're just going to have to drag across that line and actually buy pretty much the same way as we do today. Although we may be able to get some more contractual flexibility out of some of our partners. So, we'll always try and push that button. There's some things that, we'll buy as a service. But once again, as I mentioned earlier, that may just be someone taking our mess for less and trying to sell it back to us on a per use basis. And, at the end of the day, that actually doesn't really solve the agility problem. All it does is, allow someone to divide your volumes up and come up with a price and a margin. And so we think that's probably more expensive, but maybe one option we look at. And ultimately, the first bullet point there is the one we want to go after, which is how do we actually transform and really create true savings and true agility and true value to the business. And then how do we start, creating a contracting pattern in the market where we can actually take advantage of that. And really simple things we've come across, like when you sit down and talk to providers, a lot of providers today don't have a standard contract for how you buy services on a 30, 60, 90, even a 6-month basis, right? Everyone's used to signing, contracts that go for a year, 3 years, 5 years. So when you sit down and start having conversations about those sorts of things, then they're actually really tough because the guys are making a bunch of investments, and they want to get a payback on that investment, but we only want to guarantee that we're going to buy it for a period that's potentially less than that payback. So you start bumping into all these things. How do you commission salespeople? Most salespeople have been commissioned in the past, based on total contract value. So selling a $1 million deal that lasts for 5 years and they get $5 million worth of sales commission. Well, now we're saying, well, actually we just want to buy it month by month. So you're going to have to come back and see them every month and make sure I'm happy. And so we're going to kind of drip feed their commission to them. All those sorts of things. How do you value a business? A lot of these big outsourcing businesses are valued on locked-in contract value, and all of a sudden now they're going to be running on a day-to-day or month-to-month basis. How do analysts value a business that now has a quite different risk profile around its revenue? One of the questions that I often get asked is public versus private. So they say, oh, you're a bank, you'd never stick anything on a private cloud, and I go, well, maybe not. And I think once again that's where it really comes back to workload placement. So we've got websites, or we've got things like home loan calculators or things like that have no customer data. There's no security issues. The availability requirements really aren't that extreme. And in many cases, I've got no problem at all with putting those on a public cloud. And if that's the cheapest place and the easiest place to deploy, then absolutely, that's where I'll put it. But where I have customer data and where I'm bound by regulations and things that banks have to do in terms of customer data and privacy and security, then absolutely, I'd want to put those things maybe even within my own data center, so I can guarantee that some of those things will take place. So I think as an organisation, we'll end up putting workloads in lots of different places with a number of providers, and I think there's a whole bunch of different use cases, and that's where it comes back to really making sure that you understand your workloads. And one of the real values of cloud is actually creating fit-for-purpose operating environments. So rather than sticking test, dev, production, whatever it is, all in a tier 3 data center with barbed wire fences and that are all electrocuted and security cameras and high availability networks and all the rest of it, you can actually start creating fit-for-purpose type capability, which will help us get the price right for our customers. So the point we're at now is we're just looking to scale out into production, and so we've been running a number of pilots, and we think we've got the security right. We've got some tooling which actually enables us to take essentially the platform containers that Kevin was talking about and actually land those on anything from a private cloud to a public cloud. And so we're really at a stage now where we want to start scaling out infrastructure as a service. And then, we're actually taking our own homegrown platforms and we're landing those on that infrastructure, and then we'll actually scale those up as we migrate applications onto them. So we think we're in a pretty good place. Of course, the trick here is actually application migration, and we'll talk about that in a minute. The other thing too is that I can't overstate the requirement for a strong enterprise architecture and kind of architectural governance. And so at the end of the day, I think what a lot of us are trying to do is create a much higher degree of standardization within our organizations, because that really enables a lot of the agility. And so we've done a lot of work around enterprise architecture and governance, and we really make sure we've got the right mechanisms in place. So, for example, we invest about $1 billion a year on delivering new services to our customers, and every single one of those projects, as they get funded, they actually come via the leadership team in IT, and they actually get an enterprise architecture score. So, does the data comply to the data architecture? Does the infrastructure comply to the infrastructure architecture? Is it going onto a standard platform? What does the application look like? And basically, we discourage the business from from actually deploying or working on projects that don't get the right enterprise architecture score. And we know that there's always going to be exceptions, but we really try and manage those exceptions. So as we create these new standards in terms of infrastructure, platforms and software, then we want to govern very closely or work with the business very closely in terms of enabling them to actually deploy onto those standard platforms, so we kind of stop this growing plethora of platforms and technology that we're all trying to deal with today, which actually slow us down. So some of the challenges that we've encountered, once again, I think some of these are things that all of us may be banging into. So technology, everyone's got a vision of what they think cloud can offer, whether that be from a technology point of view or a business model point of view. And I'd suggest we've still got a long way to go. So, how do I get real contestability? Well, the way I get that is by having really high workload portability. Well, I can't, most of my workloads today, I can't just kind of move around on a spot market basis. I can't buy on a spot market basis. But, I think that's clearly the place people want to get to. And so we're working really hard to kind of push those boundaries as hard as we can. Customer data, privacy, reputation, and the regulators. So banking's obviously a heavily regulated industry. And they really, and look, the bank, our core proposition to customers is actually trust, and so people really trust us with their money and with their data, and so security is absolutely key for us, and we need to make sure we manage that at all times. And we actually think we've made a lot of progress from a security perspective, so we actually don't see it as much of an issue as people think it might be. I think there's a lot of smart people solving those problems very quickly. I think one of the biggest issues we're running into is the legacy bind. So, not only from an infrastructure perspective, but around applications. So all of us have a huge, or most of us that don't work for companies that have started up in the last few years, have a massive legacy that we're dragging behind us. And, a lot of that stuff you can't just pick up and kind of put on a new, a cloud-type infrastructure. Some of the technologies that folks like VMware are coming up with that actually allow you to wrap those applications and deploy them differently. Do those help? Absolutely they do. But they don't solve every case every time. And, there's still a lot of work to do. And at the end of the day, if you go to the business and say, I want you to rewrite an application or buy a new one so I can move it onto this platform, if there's not a business case there, they'll laugh and tell it to go away. So, we've really got to help enable that if we want to really start driving this hard. And, setting standards up the stack as high as possible, I think, is also critical. So we're trying to set the standard as actually as platform as a service. So we want to buy infrastructure, we want to put our standardized platform containers on top of that, and we want to force people as much as we can, or help people, I should say, or our customers actually get into those platform containers. So we actually standardize at that level, and then we can manage all the complexity below. And, in, I don't know, 5 years, 10 years, whatever, we'll probably be saying that we're actually trying to manage at the software as a service level for standardization, but we're quite away from that yet. And we think there's even some challenges in standardising at a platform level, but that's what we're going after. And I talked a little bit about the service provider and commercial models. So once again, everybody kind of talks that up a little bit. But when you actually sit down and start negotiating with providers, then they're struggling themselves to actually figure out how do they come up with models that enable them to sell on that basis. So once again, consumer technology like Amazon, you put thousands or millions of people in a cloud service. And when numbers of them drop in and out, it's actually quite easy to manage the capacity. But if you've got some very large enterprises, that have got tens of thousands of servers like us, and you put 4 or 5 of those in a cloud, then one of them decides they don't like you anymore, or they want to move something to a different place to operate it, then that creates some really big problems for the guys who've just invested in data centers and technology to deliver that service. So that's a bit of a conundrum they need to get through. One of the, this is my last slide, and look, just a really quick example. One of the services that we created a year or two back, about a year ago now, was Oracle as a service. And what we basically did was create an Oracle platform, and we've put, I think now, something like in the order of 200 to 300 Oracle applications that run on that database grid now. And we've just driven massive efficiencies out of that. So this stuff really does work. And our ROI is about 150% at this stage, and that's actually, it's climbing and getting better all the time as we get better at this. As you can see on there, the charge that we charge the business is 40 to 50% of a standalone environment. So we've saved 50 to 60% of the cost of deploying an application on an Oracle database for our customers. And at the same time, we've been able to actually improve the service, so we can deploy it in days or hours, not weeks or months. And we've been able to really make sure we shore up things like disaster recovery, and we've been able to come up with things like common management patterns, that actually allow us to operate those services at a much higher level of availability. So, look, let me leave it there. Certainly happy to take questions after Ken's wrapped up. Thanks.
Thanks, Nick. So just, kind of summarize, we can get to the questions part. So as you heard from Nick, enterprises, I hear this story quite often. Enterprises and large enterprises at that are looking at ways to get more flexibility, have more agility in their environment. They're looking for services that they can show business back to, show value back to the business. The architecture that we kind of talked about here, this virtual private data center architecture, does look at consolidating of services, looks at consolidating of devices and the software containers, but it does it in a logical way so that you can, allow those containers to be more flexible, and how you build them together and offer them in a service catalog, how your businesses would consume those containers. And then providing multiple levels of service. Not all cloud, one size doesn't fit all. So you want to be able to provide different levels of service, different types of catalog attributes that different services might want to leverage from the business. And then the last thing is, that kind of drilling in that concept of, being able to offer those different services and measure and provide that value back to the customer. And so thank you for your time, and we're happy to take questions. Yeah.
You talked about network SLAs and quality of service. Do you see that your customers will ask for capacity management services like language guarantee?
So the question was, we talked about quality of service and bandwidth guarantees, and do we actually have customers who are asking for those? And the answer is definitely yes. Not just at the network level, but also at the compute level, so guarantees around the compute resources, and also guarantees around the data store and isolation of the data store. So thank you.
That Oracle service, I guess you can't give away all the info, but I'm just curious, is that running on VMware at the lower level?
No.
So it's all physical? Is it using like the rack stuff, or?
Yeah, so we're actually just it's running on Solaris, and we're actually just about to move that to some of the new Oracle technology that's coming out. So it's not virtualized as such; it's really running as a grid. So.
Shucks, I want one of these days to have a huge company say that, oh yeah, we're using VMware, so I can take it back to my Oracle guy.
Yeah, I mean, this works pretty well though, and we'll keep driving it forward.
Yeah.
Kind of a bit of a technical question, I guess. I've been building cloud products the last 2 years, and you guys talk about scalability and stuff. And you guys go into some of the issues with the CVs for legacy applications, customers having to bring in their AS400 systems and actually install them in the data center along with
Yep.
the virtualized environment. One of the big things we're running into though is scalability. We find that one data center, a couple of data center, about 7,000 VMs. Beyond that, really where we're running into scalability issues is on the networking side, and it has to do with like VLAN limitations. I don't know if this is right more of that question, but
Yeah, definitely.
dealing with that, those VLAN limitations, as a segment of customers,
Yep.
containers, that's how you do it, right?
So there is some segmentation of customers by VLAN, but to get away from the network limitation on VLANs, I'm using port groups within the virtualized environment. And so from a virtualization standpoint, I can have the same VLAN with different port groups.
Okay, so are these within sort of like virtual containers?
They're within virtual containers, and they're serviced by different network components. So that at the top level of your network, you still have the issue with how many VLANs they can support per card. But and with 10 gig Ethernet, you have a lot of VMs you can put onto that network, right? So you're definitely right. There are limitations around the VLANs. We can talk more about some of the networking stuff if you want in more detail. There are also limitations around the SAN and the number of VMDKs you can put on a VM, on a physical, on a logical LUN, and the amount of LUNs you can put into a physical spindle, right? So there are limitations all across the infrastructure, and managing those limitations, I think, is really cool problem to solve, because you kind of build a nice matrix of what are the different tweaks and what are the different components you need to measure. You need to measure these components to see when they start getting out of whack. But then I think what's more important is how do you then expand or grow your capacity to meet the business needs once you see one of those, like maybe it's VLAN. Once you hit a certain VLAN number, how do you expand your capacity to get away from that VLAN limitation, but not delay the business from deploying their application because you ran out of VLANs, right? So, right. Marrying them and getting the... Yeah, definitely. As you can tell, I love that conversation, so I could talk for a long time. So, any other questions? Yeah.
Just a question for you. That moved into your banking business for cloud as a service. I mean, this is a basic question. Do you think, with what you've been through, that the industry was actually ready for your demands? Or did you run into a lot of, well, we can't do that, but get back in a month, we'll be ready as some engineering on the fly? So basically my question is, do you think the industry as it is now was for when you started, was it ready for you and your demands, or you still see a whole lot of stuff that's got to be figured out?
Yeah, look, I think from my perspective, it certainly wasn't ready a year or so ago. I think is it becoming ready in a real hurry? Absolutely. Is there a long way to go to get to the place where we'd all really like to get to? Absolutely. So, if you look at folks like Savvis, for example, who we've done a bit of work with, there's no doubt that those guys have figured a lot of stuff out, and they can provide services today which work for us. And I think one of the things that we've tried to do is, we had a couple of ways to go about this. We could kind of wait for the industry and the technology and then figure out what time we wanted to jump into it, or we could actually try and drive some of that and get to those benefits faster and try and use that as a strategic advantage. And we took that latter path, and in fact, we are involved in other forums. For example, we're one of the founder members into an organisation called the ECLC, which is the Enterprise Cloud Leaders Consortium. And that's a body that we've set up with a number of banks and now other large institutions globally. And what we're trying to do is actually create some documentation around what is it that customers want to buy. So we're not telling anyone how to put it together. What we're saying is, as large organisations globally, and we've now got organisations in kind of Europe, Asia Pacific, and the US, and we're starting to try and document things like how do we want to buy services, and hey, we want those services to be API based so we can click them into our service models, and all those types of things, and just give our view, and then try and create a conversation with the market so we can actually help try and guide them as to what it is that large corporations want to buy in terms of enterprise grade cloud. So that's the view we've taken. We want to try and push things along, and I think there's still a huge amount of work to do, but there's stuff today you can really do, and Savvis and other folks out there in the market can they can do some of that stuff for you today. Yeah, look, we're working with a few folks, and yeah, you're right. At the end of the day, you've got to nut out some commercial terms, but certainly we've found that given it's such an immature market, then actually understanding the issues from both perspectives actually helps accelerate people into providing those right solutions, and that's the view we've taken. So rather than sitting back and being a fast follower, we actually want to try and help create the market that looks something like what we want. And we've found some like-minded people and large banks or consumer companies around the globe who are joining us to help create that view. And we all have the views are pretty similar. And I think some of the providers that we've been working with actually really appreciate getting a view from enterprise customers saying, actually we don't want to buy it that way, we want to buy it this way, or we think this is an issue and that's not. And it helps them figure out where they put their resources and their time and effort and investment.
Definitely. Yes.
You mentioned at the 400 IT type products or infrastructure type of products in-house. What percentage or any of those, if you can talk about them, are hybrid that touch both sides, both in the public cloud and also on inside infrastructure? Okay, we talk about.
So look, today those in fact I think we have precisely 452 products, but those are a mixture of things. So in some cases they are basically technology things like a phone or a desktop or a desk phone or a server or a network connection or whatever it might be. And what we're doing more and more is all those products we'll still need, but we're trying to collapse those into services. So the idea is that in a couple of years' time, instead of having 450 products that we have to assemble every time, that we can just pre-assemble those and sell them as standard services. So the analogy I use with people is we want to sell cars, not car parts. And so we're in the business of trying to put together those cars and actually sell those cars to consumers. And today, we really only have a small number that are actually looking like cars, but we have some kind of half-assembled cars and some car parts, and we've got a lot of different things in a lot of different places, and we're just trying to advance those as quickly as we can. And I don't know how many products we ultimately end up with, but it should be 50, something of that order of magnitude. And that's kind of the approach we're taking. But I guess my point around that was it's been actually creating that product or abstraction layer and becoming very customer focused about, so one of the folks that has one of those jobs is in the room here, Rod, and so he spends a huge amount of time with customers, just like any other product person in organisations that want to sell things, really trying to understand what it is the customer wants and then how we buy the components out of the market and assemble those and price them and deliver them to our internal customers in a way that makes sense. And when we first set that up a couple of years ago, everyone went, you guys are smoking something. It's, you're an IT shop. Why do you need product guys, right? You just do technology stuff. But I think, they've come to appreciate it in two ways. One is that we're very focused on providing things to them based on their requirements, and we've created some life cycles through that, so we continue to reinvest and drive those products forward. But secondly, it's actually enabled us to get very granular about how those things are priced and understand input costs and volumes and pricing mechanisms, and that's a really critical component as you move to, cloud. Because if you buy those services, you're going to have to put other things together with them to allow the business to consume them. That in very few cases, are business people wanting to log onto a website and spin up a VM, and put an application on it, right? I mean, so we're going to have to do some of that stuff for them and help deliver that as a running application, that's monitored, service managed, build, all the rest of it. So, we're talking a lot about how we assemble that in terms of a product and how do you price it and, how do you position it given the current products, and how do you actually create a product that attracts the business to it, so we're not trying to force them into it through governance. We're actually, they're actually running at it going, I really like that and I want to get onto it. And so, the best problem for me is to have more demand than I can deal with. So it's in my view, that was one of the best things we did 2 years ago to set us up in terms of a business model.
Well, thank you all for your time.
Yeah, thank you.